Hello everyone, this is a deep dive about the Katello, Foreman, Docker build service integration. We had a deep dive some time ago about the first phase when we were able to build the images and initiate these from the Katello using the Katello content views as the content and getting the images back to the Katello/pulp registry. So we proceeded with the next phase. And Adam will be talking more about it with the live demo included. So, Adam, go for it.
Hello. First, I'd like to thank Ivan for introducing me and the project. So, let's get started. First, some slides. I'll go over this really quickly because Ivan mostly said it all. We are trying to introduce Katello's patch management to Docker images and extend the publish and promote workflow people are used to by giving the ability to build and update Docker images. Why are we trying to do that? Because containers, and especially Docker, are gaining popularity really quickly now. So we need to handle this situation. Foreman Docker allows people to deploy containers from Foreman, but at the moment there's no way to manage which versions of packages end up on the images when you run Docker build or something, unless you specify the versions directly. Well, just a quick note for people who haven't seen the last demo. First, what do we need to even try and run something? We need to have proper infrastructure. The picture below shows that I have my laptop connected to the internet, and I'm running two virtual machines. One with Foreman and Katello, and second one with Docker, which I use as the builder machine and as a DNS server. I need DNS because the containers need to be able to resolve the host name of the server running Foreman and Katello. Otherwise, it wouldn't work, and getting DNS up and running isn't that hard. How does it work? We use doc, a Python library with command line interface, to build images inside containers. And to get the right content inside the images, we use Subscription Manager to register to content views and to environments using activation keys. Now, overview of the build. When the build is triggered, let's suppose the user has provided all the necessary input. I'll get to that later. Katello instructs Docker to run the builder container. Docker proceeds to pull the builder image, which it's supposed to run, and runs it. Once the container is launched, it pulls the provided Git repository, which should contain the Docker file, runs pre-built plugins, which we use to modify the Docker file to add the commands for registering into Katello. Next step is pulling the base image, which can optionally be pulled from Katello. When the image is pulled, build of the modified Docker file is started. Once the new image container is started, it registers with the provided activation key and uses RPMs from Katello. When the build is finished, the builder container runs the post-build plugins. I use one post-build plugin to refresh package list in bulb, but more about it later. And Katello then destroys the builder container and saves the newly built Docker image from the Docker daemon. Well, what changed from the last demo. Many UI changes. The UI for creating Docker images is reworked. There are some internal changes when building images, like the interfaces were changed and so on. And there was added the possibility for doing bulk builds, automatic builds, the possibility to represent Docker images as content hosts. Why we like this, I'll talk about it later, and updates of images. In order to do bulk build of something, we need a template, or we can just build me 10 instances of something without telling how the something should look. Because of this, I created the build configuration object, which is sort of large because it needs to know all sorts of stuff. And mostly the input the user had to provide for creating a Docker image is stored in this object. So the font can be sort of small, so I'll describe it. The build config has the URL of the Git repository. Optionally, it can have the hash of the Git commit if you want to specify precisely which one. It has a string of base image tag and an activation key prefix. By default, it creates an activation key with name docker-o dash environment name dash content view name. One can, if someone wants to, for some reason, have another prefix instead of docker-o, he can specify it as the activation key prefix. The user specifies a content view for the image build config, from which the content is pulled. It also has to have a repository in which the build images should end up. And there's a bunch of optional stuff like base image environment. Again, I'll talk about it later. Content view version and Docker image, the one that is used as a base for the build, and the image that was built using this config. Another new feature are automatic builds. Why would we want to have something like automatic builds? Some people might want to have images with the latest bleeding edge packages present and don't want to care about them much. Also, it was a proof of concept for doing builds without users' intervention, because they should just work on their own. They could be modified to react to GitHub webhooks. Someone asked for this on the end of the last demo, so this could definitely be used. But there's one issue. When a user is triggering a build, he normally selects a compute resource. And because this is all automated, I came up with a build resource object. The build resource is really simple compared to the build image config. All it has one compute resource and belongs to a number of organizations and locations. It's basically a way of saying, in those organizations and locations, if you do something automatic, pick this compute resource. representing Docker images as content hosts. It's another new feature. The basic use for it is that we get a package list with all sorts of information, versions, you name it. This allows us to see which packages need updating, which packages are outdated in the base image and which belong to this particular image, and allows us to use pulp to compute errata applicability. The binding between content hosts and Docker images is done at the end of the build, because when the container registers to Katello, it creates a content host. So after the build is finished, we just create a binding between those two. Updates, another feature. Because of the layered nature of Docker images, we need to know which updates belong to our layer, the one which we call the image, and which belong to the base image. Because let's consider this situation. You have a base image, and an update is available for that base image. Okay, you update it, everyone is happy. But when you build another image using the other one as its base, and then both of these images, the lower one and the upper one, has the same update available. Well, you could apply the update to the upper one, which would update, well, obviously, the upper one. But it would be much better and space-saving if you could just update the lower image and then rebuild the other layer atop of the newly built, updated base image. There's also need to handle dependencies when updating images. Again, because they are built one atop another, the best approach is, again, to build the lower ones first and then layer the newer ones atop of them. I handle this by building a dependency tree of the images and launching bulk builds in levels of the tree. There's one specific case where the update should fail. Consider this situation. You have an image in the production environment, and you have built another image based on the image one, the one in the production environment. When an update becomes available from the image one, it's logically available for the image 2 as well. But there's one thing I haven't told yet. When you build an image, it always ends in the library environment. Always. So if you would take both these images and run an update, the image one would get updated and end up in the library environment. But the image 2 would still be built on top of the image one from production. So to handle this situation, the possibly cleanest solution is just fail the whole build and make the user update the image one first, move it through all his environments, QA, whatnot, and after the image has been promoted back to production, update image 2. Well, now for the practical part. If you've seen the previous demo, you may remember that the UI for Docker images looked sort of different. The new Docker image form remains basically the same. You fill in a git URL, git commit hash. New thing, you can select base image environment, because if you have many images, it might be difficult to find out the correct one in simple Dropbox. Because of this, I introduced this path picker, so you can filter them by environment first. So let's say we want to build on some image from production and have only this CentOS image present. Yeah, I don't have any compute resources defined in this organization, sorry, but I could select a compute resource if I had one, an environment from which it should pull the content, a content view which it should use to provide the content, and the pulp repository where the image should end up. I won't launch the build because it takes way too long for the purpose of this demo. So I'll just refresh. Meanwhile, I have a repository where in master I have from CentOS, CentOS 7, run, yum install, bear, and camel. Those are stub packages I have in Katello. Using the same repository but different commit hashes, I have one which doesn't install bear and camel but installs crow, and one which installs subscription manager. To speed up the builds, I take a base image of CentOS, create a base image from it with subscription manager present, so none of the builds that are based on this have to install subscription manager and all its dependencies again. It's just to save a bit of time. And lately, I have a Docker file installing a specific version of rhn config just to show you some erratas. Well, now finally, the Docker images page or index is all loaded. And what can we see here? It's a table allowing bulk updates. So we can select bulk updates, select some images, and run the update. There is no compute resource picker. It just uses the build resource if you have some set. What we can see here, we can see the image ID provided by Docker, which is mostly human unreadable, but well, it's a human readable name, which is formed as a repository name colon tag. Available updates. Here we see the traditional errata pictograms, and we can see that this image has two packages which have different version from the one available in its subscribed content view and environment, and 0 packages which need updating inherited from its base image. We can see that it was based on this image, which is my version of CentOS with subscription manager installed. That the base image is the latest version. I'll talk about this later. And that the image is updatable. That means that we know how to update it. Though we can update only images that were built using the Docker image build config object. We cannot rebuild images synchronized from external sources or imported as tarballs because, frankly, we don't know how to rebuild them. There's just no way for us to guess that. Let's pick, this one is interesting. If we look at the detail of the image, we can see content of the image which are all packages and their versions present on the image, and which packages could be updated. We can see that rhn config can be updated, and it belongs to the top level layer. We can also see that subscription manager and Python RHSM need updating as well, but are inherited from this base image. We can also see errata working here. If we click on that, we get redirected to the content host that represents this Docker image. And after it loads, we can see all the applicable errata. Well, so much for Docker images. Let's take a look at the Docker image build configs. Great. We can, of course, create a new Docker image build config, which is the first thing a person should usually do. Again, this form is really similar to that when creating Docker images, with one difference. There is no environment selector for the content. When you are using Docker image build config object, the content always comes from the library, and the image always ends in the library. We can fill git URL, commit hash, activation key prefix, select base image, content view, target pulp repository, and enable the automatic builds. I have several images or image build configs created. The one I use as a base for all my images is this CentOS. It's built from the default organization view. The image ends in the CentOS repository, and there's no, it doesn't have a base image provided by Katello. It's just built from the one that is provided in the Docker file, which means it's built from CentOS 7. My other configs, such as CamelBear and rhn config, are built from this CentOS, and Crow is the only one that's built on top of CamelBear. We could, again, select bulk build, select all these images, and let them build. Again, it would take way too much time, so skip that. And now that I mentioned that Crow is based on CamelBear, I can go back to Docker images and explain the last column I haven't talked about yet. Come on, faster, faster. This column, based on outdated image. What does it mean? I built a CamelBear image. After that, I built a Crow image on top of this CamelBear. After I did that, I published a new version and created another CamelBear image, which basically overrode the old one. And when that happened, the Crow became based on outdated image, because the image it was based on originally has been replaced by another image. That's what it basically means. Well, probably the last thing I will show is the build resource, which, again, if you remember the diagram, which is really simple. The only thing you can set for it is its name, and choose a compute resource for it, and set some locations and organizations. That's all there is to it. So That would somewhat conclude my deep dive, and I would like to hear some questions, maybe.
Okay, so we have some questions on the Q&A forum, so I will read it for you. Michal said that it would be helpful to specify the path on the Git repository, as some people used to have more Docker files in one Git repository.
Yeah, it would really be good to have this possibility. As far as I know, there should be a way to do it. Doc, if I remember correctly, supports it, so it would be just a minor modification of the UI and the config object, and it would be totally doable.
Mm-hmm. Okay, thanks. Also, so if I understand it correctly, when you have when I then publish a new content view or new version of a specific content view that has the build config defined with the auto building turned on, it will mean that after the publishing is finished, the building of the new image for this specific version starts, right?
Yes, exactly.
Is there also some link between the build image and the specific version that was used for that build, and is it visible somewhere?
Yes, there is a link between an image and its build config, and there is a link between the build config and a content view version, which was used to build it. But so far, there's no possibility to see that in the UI. One would have to go to the console and look up the object.
I think that might be also useful to, and maybe that's we would get to this stage if this project becomes part of the catalog, where you could see the versions and the images at every version, the images that correspond or the Docker images that represent this version.
Yeah, that would be good. I'm sorry, Ivan is muted.
Yeah, I'm sorry. So I don't see any other the questions right now. We'll the deep dive is recorded. We will send the links as well as the wrap-up email on the Foreman Dev channel or the mailing list, and we can follow up the discussion there or just reach to us on the Foreman Dev channel. So Adam, anything else you want to add right now?
Well, probably not. Nothing I can think of right now.
Okay. So thank you very much for the deep dive, and see you all later.
Thanks for having me here. See you later.
Bye.
Bye.